solving questions on introduction of partial differential equation. Now, if we are given a partial differential equation of uxx is equal to 0, there's only two approaches that comes to mind. First, you can rewrite this partial differential equation as partial square u over partial x squared is equal to 0. And then you integrate both sides with respect to x. So realize that if you integrate it for the first time, you get partial u over partial x is equal to, and then since we are integrating with respect to x, you choose which variable that should represent your constant. But since we are dealing with a partial differential equation, we are dealing more of a constant function than a constant. So if I integrate this, I'll have f of y, where a function of y is representing my constant. Now, we have to integrate again to get our final solution. So if I integrate both sides, I have that. So I have integral of partial u is equal to integral of partial f of y partial x. But since we are integrating with respect to x, the f of y here represents a constant. So we can factorize f of y out, and then we have integral of partial x is equal to integral of partial u. So if I integrate this, I'll have u is equal to f of y, the integral for this, since we have 1 here, is x plus our constant, but we are dealing with a constant function, and we are integrating with respect to x again. So we have g of y like that. So therefore, the solution for this partial differential equation is equal to x, f of y plus j f of y. That is the first approach if you want to use the normal integral approach to solve this partial differential equation. The other method is to assume that you are solving ordinary differential equation. If we solve ordinary differential equation, I can give you y prime prime is equal to 0. The only thing that comes to mind is let y be equal to, which is the solution, be equal to e to the power rt. Therefore, y prime will be equal to r e to the power rt, and then y prime prime will be equal to r squared e to the power rt. So wherever we see y prime prime, we put its expression there. So we have y prime prime is equal to 0, but we know that y prime prime is equal to r squared e to the power rt is equal to 0. So it seems like we have two terms multiplying here. We have a multiplying b is equal to 0. If two terms are multiplying, it's either one of them is 0 or both. So we can say that we can ask, is r squared 0 or is e to the power rt 0? But e to the power rt cannot be equal to 0. Therefore, our r squared should be equal to 0, which means that r1 is equal to 0, and then r2 is equal to 0. Recall from ordinary differential equation that this is giving us an idea of an ordinary differential equation with equal roots. And what do we learn about that? We said that anytime you have another differential equation with equal roots, we have c1 e to the power r1 t. In this case, we are dealing with t, so we have plus c2 e to the power r2 t. So this was the idea that we had under ordinary differential equation. But we are solving a problem which is a partial differential equation. It means that wherever we see c1, and C2, we are not putting a constant, but rather a function of a constant. A function of a constant in respect to what we are integrating. So in this case, we are integrating with respect to x. So it means that a function of y is representing as a constant. Therefore, wherever I see a constant c, I can represent here by f of a function of a constant, which is f of y. And then we know that r1 is 0. So this expression will give us 1. r2 is equal to 0. So we have x here because it is a repeated root. So we have g of y, which is another constant function, multiplying x and then times 1. It means that u of x, y is equal to that. So this is the first approach, and the second approach solving